Hey guys, so in the last lecture, we have seen vapor dominated uh, thermal power system, geothermal power system. So today we will see liquid dominated, that is wet steam geothermal systems. So as the name suggests, that it is dominated with the liquid and not the vapor. So, in liquid dominated geothermal power plants are run when the geothermal fluid is the mixture of water and steam. So, if this is the geothermal fluid, then it can run in the liquid. In the liquid dominated geothermal reservoir, hot water with various degree of salinity. This salinity at a wide range of temperatures available. Due to high pressure, the water does not boils at high temperature and it remains in the liquid state. So, when water comes to the surface, the pressure is reduced and rapid boiling then occurs, and the liquid water flashes into the mixture of hot water and steam. So the dry steam can be separated and used to generate electricity. So this steam can be separated and can be used to generate electricity. And the remaining hot water can be utilized for process heating purposes. So liquid dominated power plants can be classified in three categories mainly based on temperature. There is high temperature system, that is if it is greater than 180 degrees Celsius. Then comes moderate temperature system if it is between 90 to 180 degrees Celsius. Then there is third, uh, low temperature system, that is less than 150 degrees Celsius. So here this is liquid dominated flash steam system, this total flow system. Here in medium you can have liquid dominated binary cycle system, and low you can have hot water system. So we'll see all the three systems based on different temperature ranges having similar construction but with a few difference. So we will see, we'll start with liquid dominated flashed steam system. So in this high temperature liquid dominated system, water is above 180 degrees Celsius. So however, due to high pressure, the water does not boils at a high temperature. It remains in liquid state. But as I told before, that when water comes to the surface, the pressure is reduced and rapid boiling then occurs. The liquid water flashes into mixture of hot water and steam. So a general layout will be geothermal fluid, that is steam plus hot water, will go to suppose hot water. So this is suppose hot water is required. So this hot water will move from a flash steam separator. There is flash steam separator. So here this the hot water is converted into the steam. It is separated. It is passed to the steam turbine, and then it is passed to generator. So not then due to the turbine rotation, it is coupled with generators, it will generate electricity, and the steam is phased out from the turbine. So production well delivers a mixture of hot water and steam to the flash separator. The steam and water are separated. So here the steam and water separated. Steam is supplied to the steam turbine, which is coupled with this electric generator. So the discharge of the steam turbine is passes through a direct contact type condenser. The part of condensate is circulated through the cooling tower. Water coming from the condenser and cooling tower is re-injected to re-injection wells, and the remaining highly saline water, that is called brine, is from separator, can be used for direct thermal applications and then re-injected to the ground. So this is the whole concept of liquid flash geothermal power plant. So we will again uh, draw this whole power plant. So all the same components are there. So so from here, suppose geothermal fluid is taken and it is passed through flash separator. This is flash separator, and this is passed through a turbine. So then it is passed through a condenser, and this turbine is coupled with a generator, and after passing through this condenser is coupled with a cooling tower where the water is cooled. So this is a cooling tower, and then from this condenser it is injected back to the ground, and there is a water circulation here. There is cold water circulation from condenser to the cooling tower, and so on. So that is so this is the whole geothermal power plant. So now we will see a similar second system, that is, if the temperature is little bit low, it is around 90 to 180 degrees Celsius. So that is liquid dominated. It is liquid dominated binary cycle system. So this is a binary cycle system. So flash steam system is not suitable for geothermal fluid having low or moderate temperature, because this temperature is not enough for efficient flash steam production. Also, there is need of bulky flash separator when geothermal fluid having higher content of dissolved minerals. Others, other, other components in working fluids faces the corrosion problem. So, in this binary cycle, has two cycles with a common heat exchanger. So, the geothermal fluid, so that is geothermal fluid, that is steam plus hot water, extracted by a production well. So it is extracted by a production well, circulates only through heat exchanger. So it circulates only through heat exchanger, and in heat exchanger the geothermal fluids gives up this geothermal fluid gives up heat to low boiling point working fluid, normally volatile organic fluids such as isobutane, freon, propane, ammonia, etc. So here is the working fluid, and then it moves through the vapor driven turbine and electricity is generated. So there is the heat is being passed to another com- another another component, that is freon, propane or ammonia. So liquid dominated binary cycle geothermal power plants consist of two heat exchanger, turbine, surface condenser, cooling tower and electric generator. Hot water or brine from the underground reservoir is circulated through a primary heat exchanger. So let's draw again to understand. So suppose this is the ground, and suppose from here the hot water is taken and it is uh, re-injected back to the ground, and from here, through heat exchanger, the heat has been taken from this hot water. So the heat has been taken from this hot water to the another component, that is, suppose isobutane, ammonia, or anything else. So then this is passed through a turbine and it will provide electricity because it is connected to generator. Then this turbine is then again passed. Then this turbine is then this isobutane is passed through another heat exchanger. So this is passed through an heat exchanger, and it is it is then it is then cooled. This is then cooled with the help of condenser. So this is then cooled with the help of condenser and cooling tower. So this is connected to a cooling tower and so on. So this is the concept. So here there is a change, that here we are using a heat exchanger instead of flash flash steam separator, and also so and also this is the temperature is a little bit low. So the liquid isobutane turns into superheated vapor, and this superheated vapor is expanded in the turbine. So the exhaust vapor from the turbine is cooled into regenerative heat exchanger and then condensed in the condenser. The condensed liquid isobutane is returned to primary heat exchanger by the way of regenerative heat exchanger. So main advantages of binary fluid systems are that is there is no problem of corrosion or scaling in the working fluid circuit. Low temperature geothermal fluid can be utilized for power generation. Geothermal fluid is returned to the earth, and there is no environmental power associated with the hydrogen sulfide emission, and in some cases higher conversion efficiencies than flash steam systems is found. So this is somewhat more useful than the flash steam separator power plant. Then the third power plant is the liquid dominated hot water system. So liquid dominated hot water system. So in this hot water system, so this this has very low temperature of hot water. So liquid dominated reservoirs are most numerous hydrothermal resources in the world. So it can provide direct heat for residential, commercial, industrial, agricultural buildings, including greenhouses and animal shelters. And for food and industrial processes, hot water can be utilized for refrigeration and air conditioning. So the energy of hot water resource can be utilized in a hybrid system consists of a geothermal conventional system. In this system, hot water resource is used to preheat feed water and for air for combustion. So the liquid dominated water system, the hot water is brought to the surface where the heat exchanger transfers the heat to another fluid such as liquid or air, which distributes the heat at required places. And the geothermal fluid can be directly used if the salt and solid content is low. So the geothermal fluid is re-injected into ground after extraction of heat. Hot water system is very economical when geothermal site situated near a heat utilization site. So it does not appear to be feasible at present to transport hot water for distances greater than 24 kilometers. This is partly because the cost of pumping, piping, etc. partly loses the heat with increase in the distance. So this is generally a simple system that you are taking the hot water and passing it to another hot air or water, whichever, with the help of an heat exchanger. This is the simple concept, and you are using that air or water. So this is, if the temperature is very low, you have no option then by only using that heat directly for the purpose rather than converting it to the electricity. So this is, so now we'll discuss the last, that is total flow system. So this is for the high temperature liquid that is greater than 180 degrees Celsius. Total flow system, geothermal power plant. The entire geothermal fluid brine is passed through special turbines. Unlike steam is separated from the brine in flash system, or heat is extracted from the brine in the binary system. So the geothermal fluid passes from a wellhead into the turbine and from the turbine to the condenser. So the total wellhead output is expanded in the turbine and discharged in the condenser. So let me draw it again. So suppose from here geothermal fluid, the whole brine is passed to the turbine, and here there is a generator, and then this whole brine solution is then passed to the condenser, and there is a cooling tower here. So this condenser and cooling tower will help in cooling the water, and in the similar way, uh, then it is back re-injected to the ground. So this is the concept. So the geothermal fluid passes from wellhead to turbine, and from turbine to the condenser, and the total wellhead output is expanded in the turbine and discharged into condenser. Therefore it is called a total flow concept. So there is no flash steam separator, therefore it is called total flow concept. So radial impact turbine, helical screw expanded turbine, or bladeless turbine are used in a total flow system geothermal power plant. So this is the main concept of total flow system. So here directly the brine is passed with the help of pump into the turbine, and then the power is generated. So this is the whole concept of total flow system. So now we have seen the vapor dominated and liquid dominated. So I will just point out few of the differences between them. So suppose this is vapor dominated system, this is liquid dominated system, and these are the differences, suppose, which we are going to point out. So first is simplicity. So first is simplicity. So simplicity due to directly availability of the dry stream. So directly the dry stream is available. So this is a more simple. Here there is complex due to separation of dry stream from the mixture of steam plus water. So this system is little bit complex. Minerals dissolved. So here this, as it is steam, so the minerals are less, where it is in the form of water and steam, so minerals are more. Corrosion. So here there is less corrosion because it's steam. Here there is more corrosion because it is a form of water. So there are different components. Then environment. So it's less because it is a dry stream. So here there is an impact of environment because of higher content of dissolved minerals in the geothermal fluid. Then power density. So power density. So here the power density is higher. Here it is higher due to higher temperature of geothermal fluid. Here it is less due to low temperature of geothermal fluid. So these are the differences between vapor dominated and liquid dominated. As you can see, the vapor dominated is more convenient than the liquid dominated system. So these are the main differences between the two systems. So from the next lecture we will see few geopressured resources and etc. So thank you very much, guys. So in the last lecture we have seen vapor and liquid dominated power plants. So in today's lecture we are going to see geopressured resources. So what is geopressured resources? So we'll see that, what is geopressured resources. So before that, so the geothermal fluids, that is hot water and steam, are the resources which are required for generating power. So geopressure resources occur in basin environments. So they occur in basin environments where deeply buried fluid contained in a permeable permeable sedimentary rocks. So this fluid is contained in permeable sedimentary rocks. So which are warmed, means which fluid's temperature has been raised in a normal or enhanced geothermal gradient by their great burial depth. So more is the depth, the more will be the temperature. So the fluids are tightly confined by surrounding impermeable rock. So they are confined by the impermeable rocks. So the reservoir contains moderately high temperature. So around 90 to 200 degrees Celsius. Water or brine under depth are at pressure of 1350 atmosphere. So are found at a depth of 3 to 6 kilometer. So thermal water under high pressure in sand aquifers are target for drilling. So this are target for drilling because it it may contain high dissolved methane. So a special feature of geopressured water or brine is contained large amount dissolved methane gas. So that is 1.9 to 3.8 meter cube per 1 meter cube of brine or water. So the solubility of methane in water at normal pressure is quite low, but it increases with pressure. So when the water or brine is brought to the surface and its pressure is reduced, so what will happen, that this methane gas will be released from the brine. So hence methane can be extracted from brine by simple and economical gravity separation techniques. So the source of energy available from this type of resource consists of, first, so what are the sources of energy? So first is heat energy due to high temperature. Then second is mechanical hydraulic energy due to high pressure. Then the third is the chemical energy, that is due to methane. That is, we are obtaining a fossil fuel, that is methane gas, so which we can use for direct energy conversion as a direct energy. So this is the benefit of geopressured resources. So now we will see hot dry rock resources. Hot dry rock, that is HDR resources, or petrogeothermal resources, or petrogeothermal resources. So, hot dry rock resources are defined as heat stored in rocks within 10 km of the surface from which energy cannot be economically extracted by natural hot water or steam. So, what we can do is that these hot rocks have few pore spaces or fractures. So, therefore, contain a little water and little or no interconnected permeability. So, this the temperature of hot rocks. So, the temperature of hot rocks at useful depths up to 3 km are 150 degrees Celsius to 290 degrees Celsius. So, hot dry rock resources are much more common than hydrothermal resources and more accessible. So hot dry rock represent highest about 85% of the total extractable geothermal energy deposits energy in the world. So in order to extract the heat from this hot dry rock, so what we can do is we have experimental projects involving forming an artificial man-made reservoir, that is the fractured rock. That is fractured rock. So what we can do is that by if we drill by drilling a deep hole into the hot rocks. So what we'll do this we will drill a big hole in the hot rock. So suppose this is the big hole in the hot rocks and then cracking it to form a cavity or fractures. So we will form a cavity. So this is a cavity by these fractures. So followed by circulating cold water. So then we can follow a cold water and a hot water in this cavity. So by circulating cold water we will get a hot water as output. So by circulating cold water down one well to extract the heat from the rocks and then producing a second well in the closed system. So this system is known as enhanced enhanced geothermal system. Enhanced geothermal system or engineered geothermal system. So EGS, enhanced or engineered geothermal system, and this can be achieved by main three techniques. So what are the three techniques? So first is to create a fracture produced by underground nuclear explosion or chemical explosion. Then second, to place a high explosive at the bottom of the production well. So to place a high explosive, so create a fracture, put explosive, then fracture produced by high pressure water injected, hydraulic fracturing in the existing fracture. So then we'll produce the fracture by high pressure water injected by injecting high pressure water. So that is hydraulic fracturing into the existing fracture. So these are the three steps that need to be followed to generate this geothermal engineered geothermal system. So now I will draw a block diagram that how it will work. So suppose hot dry rock. So that is HDR. It is hot dry rock. So from here we will pass water in hot dry rock. So water. So we will get steam as a output. So after, if we get the steam, so we need to separate the steam from the steam separator, because there may be possibility of water content in the steam. So we will pass through a steam separator. So after passing through the steam separator, we will get steam. So that steam will pass through the steam turbine. So we will couple the steam turbine with the generator. So we will get electricity. So here, after, we will get water in the steam generator and steam. So water will give back to the hot dry rock, but we need to also supply external water, uh, back to the hot dry rock to maintain the circulation of the water. So this is the block diagram of uh, hot dry rock, how we can generate power from HDR. So so once again I'll explain. So this shows a hot dry rock binary fluid system power plant. So the thermal energy is extracted by pumping water into the crack or fracture. So your water is being pumped to the crack or fracture from the surface and withdrawn by another well at a distance. And injection and production wells are joined to form a circulating loop. So this is created a loop through this man-made reservoir to achieve a steady flow of high temperature water or mixture of water and steam. So heat of water is transferred to second working fluid. So let me draw the uh, power plant diagram. So suppose this is a cavity. So suppose this is the cavity. Oh, wait a second. So here, as you can see, so this is an artificial fracture in the hot dry rock, which is man-made created. So heat. So from here we are passing the cold brine or cold water to the rock, and we are getting the geothermal fluid, that is hot steam plus liquid, sorry, hot brine, that is geothermal fluid. So what we are doing is just we are extracting the heat from this brine solution and passing its transfer to second working fluid, that may be isobutane. So this may be isobutane, freon, propane, ammonia, etc. So when the heat is extracted, so rocks cool down and causes an unequal cooling and thermal stresses and fractures the rock. So what will happen, that this rock can get cooled down and can have stresses and cool can can fracture the rock. So the size of the original fracture in the hot dry rock increases. So this fracture will increase, the resources keep on expanding. So this will keep on expanding. So as it is getting cold, so only hot dry rock experimental projects were undertaken. So however, these projects have been are currently working in few of the countries also, that is Australia and etc. So we'll see advantages and disadvantages of hot dry rock energy power plant. So advantages and disadvantages. Advantages and disadvantages of hot dry rock power plant. So we'll start with advantages. So advantages is more number of wells can be drilled into geothermal fluid to obtain a high flow rate, essential for large power plant. So more wells can be drilled. So to obtain a high flow rate, essential for large power plants. Then second advantage is that large geothermal resources can be trapped. So large resources can be trapped. Then third advantage is that water flow rate and temperature may be selected by the different depths of production. So rate and temperature can be selected by different depths. So how much temperature you want, so that much depth you can go. So there is an operational flexibility. So there is a flexibility for the operation. Then fifth, that the life of production well is long. It is about 10 to 30 years. After 10 to 30 years you can generate energy, heat energy from this well. So now we will see disadvantages. So there are several mechanical thermodynamic, metallurgical, and economic studies are required before finalizing the location of the plant. So many studies need to be done. So that is a disadvantage. Second, there is more chances of leakage of injected water from the man-made fractured cavities into the underground layer of the rocks. So there is a possibility of leakages due to the reduction in the temperature in the cavity. So there may be possibility of leakage. So it can move the water into the underground or other cavities. So there may be loss of water. Then third is high cost of drilled wells. So the cost is high and man-made fractures. So to construct this well is costly. So these are the disadvantage of HDR, hot dry rock resources. So then there is another resource also, that is radiogenic resource. So radiogenic resources are found where granitic 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 intrusions are near surface, heating up the local groundwater from decay of. So due to the decay of radioactive material, that is thorium, potassium, uranium, and etc. So this localized heating increases the normal geothermal gradient, providing hot water. So it can provide hot water at an economical drilling depth, and this type of resources are occurs along the US but has not been developed commercially. So this is an also a useful resource, that is radiogenic resources. So this is also a good type of resource for power generation. So these are the main topics which you discuss in geothermal energy. So we will just see in the next lecture, that is what is the geothermal energy scenario in the world and India. So that is what is the potential of this energy in the whole world. So that will give an overall idea of the development of this resource. So hope to see you in the next lecture. Thank you very much.